Hello! Today we will be solving this problem called the removal game. So there is a list of n numbers and two players who move alternatively. On each move, a player removes either the first or last number from the list, and their score increases by that number. Both players try to maximize their scores. What is the maximum possible score for the first player when both players play optimally? So the first line of our input will contain an integer n up to 5000, and the second line will contain n integers each between -a billion and a billion, and the output should be the maximum score for the first player. So in this example, the answer is 8, and to get 8, the first player will take 3, then the second player can either take 4 or 1, and regardless of his choice, the first player will then take 5 for a total score of 8. But as you can see here, greedy does not work. In the first step, the first player had a choice between 3 and 4, and he did not choose the largest value. Actually, the largest value does not lead to the optimal solution. So let's go to our drawing board and see how we can solve this problem. So before we move on to this large example, let's start with something small. Let's always start with the simplest examples. So suppose n is just 1, we only have one value, say we have 5. Then the answer in this case will be 5, because the only possible move for the first player is to pick this value. Okay? Second example, suppose we had 2 pieces and then we had 3 and 7. The answer in this case is 7, because the first player either picks this value or this one, and since 7 is larger than 3, then the answer is 7. Third example, let's say we have 3 numbers. We have 1, 5, and 2. Here the first player can either take 1, and then he will leave the second player to start with 5 and 2, and obviously the second player will take 5, so the first player will have to take 2, and that means that the score of the first player will be 3. Same thing, if the first player started with 2, he would leave the second player with 5 and 1. This means that the second player will take 5 and the first player will end up with 3 again. Now let's go back to these examples and mark down the score of the second player. Here the second player will get 0, here he will get 3, and here in this case, in both cases actually, he will get 5. So what do we notice about these values? Obviously the sum of these values is equal to the total sum, which means that the score of the first player plus the score of the second player is equal to the total sum. This is actually a tautology. There is nothing impressive about this. But what we can notice next is that if we want to maximize S1, we have to minimize S2. Since their sum is constant, maximizing one value results in the minimization of the other value. And in other words, if we try to make S1 large, this will result in making S2 small. And these two conditions will result in making the difference between S1 minus S2 as large as possible. In fact, this observation is the key to solving this problem. So in the case where n is equal to 1, this difference is basically just this value. So here the example is clear. If we have an interval of just one value, then the maximum difference will be just that value itself. In the case where we have two values, this difference will be equal to the max value over these two minus the main value. Like in this case, the difference will be 4. This basically means that whoever starts at this state will end up with a score difference of 4. And if we know that the total sum is 10, so this means that S1 plus S2 is equal to 10. And this tells us that S1 minus S2 is equal to 4. With some algebra, we will get that 2S1 is equal to 14, which means that S1 is equal to 7. So this will give us the maximum score for the first player right away. So let's continue with, we said when n was equal to 2, we could calculate the maximum difference with this formula. Now let's see what happens when n is equal to 3. So now let's see how we could calculate this difference for the case where n is equal to 3. Here we have two choices. Either we're gonna start with this value or with this value. If we start with 1, we're gonna be left with a subproblem of size 2, which we already know how to solve. And if we started with 2, we'd end up with a similar subproblem of size 2. So once we hit this point, it becomes obvious that we're gonna use some kind of dynamic programming to get the final answer from these two initial states. So if we choose to start with 1, we're gonna have a subproblem of 5 and 2. And if we choose to start with 2, we're gonna have a subproblem with 1 and 5. So here the maximum difference will be 4, and here the maximum difference will be 3. But notice that in this state it is the second player who starts playing, so he will be achieving a difference of 3. This means that his score will be larger than the first player's score by a difference of 3. And the same applies here. The score of the second player will be larger than the score of the first player by a difference of 4. So in order to get the final answer for this whole interval when the first player is starting to play, we have to take the maximum of these two scenarios. So the first scenario, the first player will pick 1, so his score, or actually the difference between his score and his opponent's score, will be 1 minus the difference that results from this state, because remember, in this state it is the second player who will start playing. So if we know the maximum difference from this state, it is going to be equal to S2 minus S1. But what we actually need to calculate here is S1 minus S2. So that's why we have to multiply the answer we get from this interval by -1, so this becomes negative S2 plus S1 plus the 1 we just got from here. So here we will have the maximum of 1 minus 5 minus 2, which is the difference we will get from this state, and 2, in case the first player starts with this 2, minus the difference we'll get from this state, which is 5 minus 1. So the answer will be the max of 3 minus 5, which is -2, and here we will get 3 minus 5, which is -2 as well. So we conclude that the maximum difference between S1 minus S2, the best we can do is -2. And we also know that S1 plus S2 is equal to 8. So with some simple algebra, we get that 2S1 is equal to 6, which implies that S1 is equal to 3. So the answer in this case is 3, and indeed 3 is the maximum value the first player can get. Now let's see how we can apply this idea to this large problem. So to reiterate what we said, we're gonna have a dp that represents the maximum difference between the first and second player. And take first and second players with a grain of salt. We mean by the first player whoever is gonna start with that interval. Maybe it is not the first player that started the whole game. So as we said, if we have an interval of length 1, say 0, 0 or 1, 1 or 5, 5, the maximum difference between the first and second player in this case will be just the value at I, whatever I is. So for example, if we consider this interval, let's get the answer for this interval. Here we know that the answer for each of these intervals alone will be just this value itself. So this is gonna be 3, this is gonna be 0, this is gonna be -9, and this is gonna be 10. Next, let's get the value of each interval of length 2. So if we have this interval of length 2, then the first player can either pick 10 and the second player will have to pick -9, or just from this, the difference, the maximum difference that can be achieved when starting this interval is -9. So the maximum difference if we start with 10 will be 10 minus -9, which is +9, which is gonna give us 19. So the answer for this interval is 19. And 19, to reiterate, is the maximum difference between the first and second player. Next, let's pick this interval. In this case, if we start with -1, then the answer we're gonna get from the second interval is 0. So the answer will be -9 minus 0, which is gonna give us a maximum difference of -9. But if we start with 0, we're gonna get 0 minus -9, which is actually 9. So the answer for this interval is 9, and it can be achieved by the first player by choosing 0. Then the second player will have to choose -9. And finally, the answer for this interval will be 0 minus 3 or 3 minus 0. So the answer is obviously 3 minus 0. So the answer for this interval is 3. Now let's move on to intervals of length 3. So the first interval will include all these elements, and basically we can either pick 10, then we have to take the difference between 10 and whatever is the maximum difference from this interval, which is gonna be 9. So the answer will be either 10 minus 9, which is 1, or we can choose to start with 0, and then the answer will be 0 minus 19, which is gonna give us -19. So it is better to get 1. So the maximum answer for this interval is actually gonna be 1. And it can be achieved by the first player by taking 10, then the second player has to take 0, then the first player again will take -9 to get a final score of 1. Now let's move on to this interval. In this case, the first player can either pick 3 and offer the second player a max difference of 9 for a total of 3 minus 9, which is -6, or he can pick -9 and offer the second player a max difference of 3 for a total of -12. So the answer is obviously -6. And finally, now we can get the answer for this whole interval. So the answer for this whole interval can be obtained either by picking 10 and offering the opponent the max difference from this interval, which is -16, which is gonna total in 10 minus -6, which is 16, or by picking 3 and offering the opponent the max difference on this interval, which is 1, for a total of 2. So obviously the best answer is 16, and it can be obtained by taking 10, then the opponent will be left with this interval. We will obviously pick 3, then we will pick 10, we'll pick 0, and finally the opponent has to pick -9, so we will get 10 and he will get -6 for a total difference of 16 as we calculated. Then we have to carry on and do the same thing with the rest of these intervals. But there are certain things that we have to notice. So when we were calculating the answer for this interval, let's say that it starts from position I to position j, so dp of ij was equal to the maximum of, like in this case it was equal to the maximum of this value, so of ai, plus dp of this interval, which would be equal to I plus 1 j, or it would be equal to aj if we were to pick this value plus dp of I j minus 1. So as you can see here, dp of I and j will depend on I plus 1, j, and I and j minus 1. So there is something very important here. When we get to value I, we should have already calculated the value I plus 1. This is very important, otherwise we wouldn't be able to get the value for I. So basically what this tells us is that we have to go through the I values in descending order. Whereas for the j values, we don't need to do that because the value for j will be only dependent on j minus 1. So the values of j can go in ascending order. So that's pretty much it. This dp will allow us to calculate the maximum difference between the first and the second player on the whole array. And after calculating the difference on this array, our answer can be easily calculated by solving that system of equations. So what we just calculated here will be s1 minus s2 equals to whatever we got, and when we get this input, we're just gonna calculate the sum of all these values. So s1 plus s2 is equal to the sum of all values. So our final answer, s1, the value we need to output, will be equal to the answer we got from our dp plus the sum divided by 2. So that's pretty much it. Let's go ahead and check out our code. So this is our program. We will start by reading n, the size of our input. Then we will declare a vector of long to store all the values. Then we will declare a vector of vectors of long, basically a two-dimensional array that will represent our dynamic programming states. And we will call this array the maximum difference for interval between I and j. And the size of this dp will be n times n. And notice that it is very important to make this dp of type long, otherwise it may overflow. Then we will initialize the total sum of all values with 0. And then we can loop through all the values from 0 to n, scanning the value and initializing the maximum difference for interval I and I, like the interval of length 1, with the values at position I, because as we said, the answer for each interval is just that value itself. Then we're gonna add this value to the total sum of all values. Next, we're gonna have two nested for loops, one for the left pointer, and as we said, our left pointer, the one for I, should increase or should go in decreasing order. Basically it should start from here and move downward, because as we said, the answer for the interval I and j is dependent on the answer for interval I plus 1j and the answer for interval I j minus 1. So that's why our left pointer goes from n-1 all the way down to 0. Then our right pointer basically has to start after the left pointer, and since we already calculated all the intervals of length 1, this right pointer can start at left plus 1 instead of just left, and it will have to go all the way up to n. And for each interval we have to calculate this maximum value. So basically we will have to get the max of either choosing the last value and getting the max difference of the rest, or choosing the first value and getting the max difference for the rest. And that's what I do here. So choosing the first value element score is equal to the values at left minus the maximum difference for interval left plus 1 right. And choosing the last element score would be equal to the values at right minus the difference for interval left right minus 1. And at the end we just set the max difference for interval left and right is equal to the maximum of choosing the first element score and the maximum of choosing the last element score. And at the end, as we said, our answer will be equal to the total sum of values plus the maximum difference for the whole interval from 0 to n-1 divided by 2. So that's pretty much it. Let's go ahead and submit. So that worked. Thank you so much for watching. See you in the next video. Bye bye.